Just picture it, an examiner's red pen literally slashing through a whole page of your complex algebra. Ouch, right? The harsh reality of Cambridge IGCSE Additional Mathematics 0606 is that sheer mathematical knowledge, it just isn't always enough to survive the marking process. You can know the math perfectly, but if you don't know the examiner's playbook, you are simply not going to get the grade. We're bypassing the fluff today and directly confronting how examiners actually grade your papers, zeroing in on the ultimate analytical tool, the discriminant.
It's the ultimate nightmare scenario, isn't it? Why do students lose critical marks, even when they absolutely 100% know the math? Think about it. You've practiced the formulas. You totally understand the theory. But in the heat of the exam, with that clock just relentlessly ticking down, grade boundaries just slip right through candidates' fingers. The tension in that exam room is incredibly real, and we're going to look at exactly where those points vanish.
And here it is, the brutal truth revealed by the examiner red pen framework. 0 method marks equals a missed grade boundary. Boom! It is literally that simple. I mean, you could calculate the perfect intersection point entirely in your head, but 0 visible method marks, that means you missed the grade boundary. The difference between scraping a B and unlocking that A star completely comes down to mastering this specific conceptual framework and understanding how marks are actually awarded. It's not just about the final number, guys. It is all about the visible trail you leave behind on that page.
Okay, let's dive into this. Section 1. Core concepts, the A-star difference.
So, according to the syllabus, the assessment objectives target exactly 3 distinct cognitive domains, just 3. We're talking about knowledge and understanding, application, and analysis. To reach that elite top band, you absolutely have to hit all 3. You really can't just memorize formulas and expect to win. You've got to evaluate evidence quality, identify limitations, and crucially recognize the underlying assumptions you're making.
Which brings us to the absolute centerpiece of our analysis today, discriminant application. So what is this? It's the analytical framework we use to determine the exact relationship between a line and a curve. Are they intersecting? Is it a tangent? Or does it just completely miss and not intersect at all? The syllabus makes it crystal clear. Top-performing students do not just memorize this rule. No way. They exhibit a fully connected conceptual understanding that transfers straight into totally unfamiliar contexts. When they see a line and a curve, they aren't just guessing. They deploy systematic analysis, checking if b squared minus 4ac is greater than, less than, or equal to 0, using hard, evidence-based reasoning.
Section 2. The technical methodology, your procedural framework.
Now for the how-to, there are 5 actionable steps you absolutely must take when tackling complex algebraic manipulation. Step 1, deconstruct the question. Step 2, extract the relevant data from any texts or tables. Step 3, select your analytical framework, like say deciding to actually use the discriminant. Step 4, execute that with crystal clear notation. And step 5, present your information using correct terminology. You've got to follow these strict conventions. Things like proper headings and clear annotations aren't just nice to have. They are an absolute requirement for drawing evidence-based conclusions.
And this brilliantly illustrates the core problem-solving cycle. Deconstruct, solve, evaluate. It's a continuous loop, kind of like a giant puzzle. You identify the given information, you break it down into logical steps, you solve it systematically, and then, and this is the absolute kicker, you evaluate. You check for reasonableness and make justified recommendations. This evaluative level, this is the exact thing that separates the average candidate from the elite. Plus, it totally saves you from accidentally stating something crazy, like a geometric shape having a negative area.
Now, what's really interesting about this next part is, well, let's get into Section 3, Evaluation and Examiner Insights, Insider Secrets from the Principal Examiner Reports.
Let's play a quick game of Spot the Error. Consider a flawed approach for a second, skipping your working out, landing on the totally wrong final answer, and providing 0 context. Honestly, that is a devastating combination. Now, compare that to an elite A-star answer. Clear steps, strict conventions followed to a T, and properly justified conclusions. See the difference? This is exactly why ordinary revision often completely fails, because if you're only checking your final answer against the back of the textbook, you are totally missing the descriptive and analytical layers that the examiners are actively hunting for.
So, the most crucial point here is summarized perfectly in a quote straight from the examiner alerts. Listen to this. Even if your final answer is wrong, method marks can save you. I really need you to internalize this method mark strategy. Marks are incredibly generously awarded for the actual process. When you show you're working logically, step by step, you're literally building yourself a safety net.
A silly arithmetic error at the very end won't destroy your grade if your analytical framework is visibly laid out right there on the page. But hey, you still have to avoid the major traps, right? The principal examiner reports specifically highlight 3 top warnings. First up, using the wrong approach for the wrong context, just a massive red flag. Second, forgetting to check your format and presentation. Remember, clear annotation and correct terminology actually matter. And third, providing answers that are just not specific to the context given in the question. You absolutely have to tailor your evidence directly to the specific scenario in front of you. No generic answers.
To help you bypass these traps, the source material actually suggests a pretty brilliant memory hack. Encode these concepts using a visual story method. Seriously, try locking the discriminant rules into your memory visually. Imagine a samurai sword physically slicing straight through a curve for 2 intersections. Or maybe it's resting gently right on the very edge for a tangent. Or it misses completely, meaning 0 intersection. Doing this kind of visual encoding allows for super rapid recall when that inevitable exam panic sets in.
Section 4. High-mark exam strategy, the red pen rescue route.
So, we've covered the theoretical foundations, we've mapped out the procedural methodology, the examiner warnings, and we know the absolute necessity of method marks. But all of this leaves us with a massive, unresolved question. You have the framework, but can you execute it before the exam clock runs out? Because let's be real, knowing the discriminant inside and out is entirely useless if you literally cannot apply it under extreme timing pressure. Knowing the math is only half the battle.
Which brings us to the mandatory next step for your exam survival. You absolutely must master the timed answer writing system. To get your hands on that system and make sure you never lose those crucial grade boundaries, you've got to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to truly excel in your Cambridge examinations. The clock is ticking, guys. You now know the examiner's playbook. So when you finally walk into that freezing cold exam hall, are you going to let the clock beat you? Or will your red pen rescue route actually save the day?